Okay, so we're going to be doing the derivatives and yes, we have a student here with us and we're going to be doing the derivatives of inverse trig and integration. So first three that you should memorize here in yellow are arc sine of whatever, secant of whatever, and arc tan. You might see it written as sine inverse, same thing. Okay. For those, you just take the derivative of whatever's in the box and you write the rest of the formula down, whether it's the square root of 1 minus box squared minus 1, or box squared plus 1. And then for these ones here, the ones in white, you just take the negative of the preceding one. So for arc cotan, it's negative d box over box squared plus 1. So let's see it in action. Best way to learn. Do as many of these as you can, right? So, Johnny, I'm gonna let you try this one based off the formula. Let's see if you can handle arctan of 4x cubed. So, arctan formula is right there. So, our box in this case is the 4x cubed. So, we have to take the. So, when we take the derivative of that, what do we get? Good. And then we divide it by the box squared, right? So is there a little bit of lag time? Okay, I'm sorry. Sometimes it does that. That's weird. It could be the rain affecting my internet connection is because it's wireless. All right. So when you square this, what do you get, Johnny? Good. Do you have any questions about that? Okay. If it was arc cotangent, the only difference is that there would be a negative sign. So if it was arc cotan of 4x cubed, the only difference is this negative sign. Do you understand that? Everything else would be the same. All right, let's try another one. Let's do arc sine of what would that be? No, not on that one. No, all that you do square the pi, but look at the formula for arc sine. It's not plus one. Right? It's 1 minus box squared. So okay, much better. What are you forgetting? Yeah. Did you say the square root and I didn't hear you? I'm sorry. If you did. Okay, so I think you're getting it. If it was arc cosine, what would the answer be? Okay. Let's do one more. Well, we're going to make it a little bit more interesting. I'll do it in a different color so that we can differentiate it from the last one. So arc I had x squared here, didn't I? I almost forgot about the x squared. And let's do arc cosecant of 3x. So these are all functions. I didn't put y equals or f of x equals, but we're just practicing here. So no need to be formal. What's your idea of this one?
Well, we would need, are we redividing the whole thing, right?
Yes, we are.
Okay, so wouldn't it be the multiplication derivative? Like the u prime v plus,
Yes. I think the words you're looking for are product rule, and it doesn't matter. It doesn't matter what it's called. You got the actual rule correct. If you assign one of them u and the other one v, the rule is u prime v. Just take the derivative of one times the other with no change, and then flip them around. So when we derive the first one, what do we get?
2x
And then times.
times arc cosecant 3x.
Good. Plus.
X squared.
Can you hear my dog snoring in the background? So funny. All right, go ahead. X squared times what?
Negative 3 over the absolute value of 3.
Of 3x. Don't. It's not the derivative of box. It's the box. Okay. Times what?
Times over 9x squared
Sorry, I'm trying to write while readjusting this heat pack on my back. I was playing racquetball the other day, and I swear I must have dislodged a rib or something. It's so painful. All right, so then you can clean this up a little bit. Are they really big on simplification in your class?
No, not really. Like when it comes to tests, if they know we have limited time, they're okay with us just
Leaving it as is?
rebuilding it.
Okay. I think this would be acceptable. So do you understand the derivatives of inverse trig now? Can we move on to integration? It's a little trickier for integration.